Hello everyone! This is our video solution to problem 8 from Superquiz 2. And, oh my, it looks like a word problem. Let's read. My son is asked at school if 150 is a perfect square, i.e. if it is an integer times itself. Well, duh, no way, man. All right, let's see. He divides 150 by 2, and after seeing the answer, immediately says, no. 150 can't be a perfect square. Good boy. All right, explain using the fundamental theorem of arithmetic how my son knew. Hey, okay. Well, let's see now. Fundamental theorem of arithmetic. That tells us if we have some, say, positive integer, we know we can factor it as a product of primes. But then there's this extra condition, right, in a unique way, right? So the fundamental theorem of arithmetic, FTOA, implies 150 has a prime factorization, right? And it's unique. Okay, well, what does that have to do with what my son did? Well, what does it mean to be a perfect square? 150 is a perfect square, right? If it's an integer times itself. So I know, of course, we can write down very easily a prime factorization of 150, but that's not what my son did. He just divided by 2 and then said, boom, it's not a perfect square. So let's explain this, right, by writing down just a generic prime factorization, right? So it would look like P1 to the A1, P2 to the A2, dot, 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 Pn to the A sub n. Now, if this number were a perfect square, what would the prime factorization have to look like? Well, let's say we just had some other number, right? Who knows what it is? Let's call it L. And L has a prime factorization, Q1 to the B1 times Q2 to the B2, dot, 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 Qm to the Bm. And if I square this integer, I end up with Q1 to the 2 times B1 and Q2 to the 2 times B2, dot, 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 Qm to the 2 times Bm. So when I square an integer, the result, when I look at the prime factorization, is going to be a prime factorization where all of the exponents are even. So if, or we'll say every prime factor in a perfect square occurs an even number of times. So 150 has this prime factorization, this generic one, but actually my son divided by 2 because he said, oh, 150 is even. So one of these primes is actually 2. And what happened after he divided by 2? He ended up with 75. We know that. 150 divided by 2 is equal to 75, which is not divisible by 2, right? Not divisible by 2. So this 2 can only occur one time as a factor of 150, right? In any prime factorization, because prime factorizations are unique. But we just said, if 150 was a perfect square, each exponent on a prime factor must be an even number, right? Or if you like, 2 must be a factor an even number of times. But it's not. So automatically, without doing any of the rest of the prime factorization, we know that 150 is not a perfect square. Right? In fact, you could generalize this. Right? If you can somehow show that you find some prime in whatever number you're looking at, right? So somebody just gives you some really, huge number. Like maybe they give you, I don't know, 1, 2, 3, 4, 5, 6, 7, 8. I bet you thought I was going to say 9. 6. That's right, 6. All right. Now, if I add up all the numbers here, okay, 1 plus 2 plus 3 is 6, plus 4 is 10, 15, 21, 28, 36, 42, right? So the sum, the digit sum, is equal to 42. Now we have a divisibility law which says if the digit sum is divisible by 3, then the original number is divisible by 3. So 3 is a divisor of this number. But we also have a 9 divisibility rule which says, again, if the digit sum is divisible by 9, then the original number is divisible by 9, and vice versa. Well, 42 is not divisible by 9. 9 is not a divisor of 1, 2, 3, 4, 5, 6, 7, 8, 6. Well, what does that tell us? 3 is only a factor a single time, and therefore this number is not a perfect square. There we go. Man, my son's pretty smart.